Good afternoon, everyone. It is September 1st, and this is episode 1 of Rob Explains, your daily podcast discussing and explaining cool, random, and interesting things. Today's topic, colliding galaxies. And let me tell you why we're going to talk about that on episode 1. A few weeks ago on the O The Anthem Podcast, the weekly podcast I do with my buddy Corey, you can find more information about that at otheanthem.com or at otheanthem on all your social media networks. We were discussing the Fujiwhara Effect as it pertains to Hurricane Marco and Hurricane Laura possibly meeting in the Gulf of Mexico. And I said I found some really cool animations of the Fujiwhara Effect. Now, I'm going to talk about that in a few episodes, so hold tight about the Fujiwhara Effect. But I said it reminded me of an animation I saw about colliding galaxies. And I had a couple of people ask me, what do you mean colliding galaxies? So I thought, let's lead off with an amazing astronomical galactic universal topic like colliding galaxies. Now, to kind of talk about this, we have to start at the very beginning, but I also want to kind of start close to home. When talking about colliding galaxies, we can talk about any number of randomly numbered galaxies that we've observed and them colliding. But what about our home galaxy? We, here on Earth, in the solar system, are on one of the spiral arms of the Milky Way galaxy. It's called the Milky Way because from our perspective, we can't really see the entire galaxy. We only see it from the edge, and all of that light pollution makes it look white, and ancient astronomers thought that it looked like a Milky River, so we called it the Milky Way. One of our closest galactic neighbors is the Andromeda Galaxy. Now, it wasn't always known as the Andromeda Galaxy. It used to be known as the Andromeda Nebula. That was because we, for a very long time, thought that there was only one galaxy. They thought everything was in the same galaxy and that the universe was very small. Edwin Hubble, whose name you may recognize from the Space Telescope, yes, that's named after him, after doing some observations, realized that there are objects in the sky that are shifted red and blue. What we can know from that is that objects that shift their light red are moving away from us, and objects that are shifting blue are moving towards us. Now, this isn't true when you're looking at a car traveling towards you. It's not nearly far enough away, and it's not moving nearly fast enough. But when objects are moving extremely fast and they're extremely far away, the red shift, blue shift tells us which direction they're moving. This was happening around the time that people were realizing that we are not alone in the universe. Now, I don't mean that by saying intelligent life. What I mean is there are more than one galaxy. We are all in one planet, in one small part of a small galaxy. And there are billions and billions of galaxies with billions and billions of stars out there. One of those is the Andromeda Galaxy. Once we had some better observation equipment, we realized that this fuzzy mass that we were calling a nebula was actually another galaxy full of stars and moving towards us, or so Edwin Hubble said. Well, here's some sad news, folks. In about 3.6 billion years, the Andromeda Galaxy and the Milky Way Galaxy will begin tidally impacting each other, meaning their gravity will start impacting the other. And sometime after that, a little after 4 billion years, those two galaxies will actually collide. And that collision will look a lot like a dance. Now, if you're watching on YouTube, you'll see this animation of the two galaxies and the way that their gravities intertwine. The center of the galaxy for each spiral galaxy is a supermassive black hole. These are objects that have unbelievable mass and unbelievable gravity. So as they pass each other, they then begin this slow dance of circling and circling and circling. Inevitably, a few billion years or less after they first impact each other, those two supermassive black holes will collide themselves. And because Andromeda's is so much larger than our own, it's likely that theirs will swallow ours. And the two galaxies will become one galaxy, no longer spiral, more likely elliptical or an elongated circle. But in the time in between that first tidal pull and the coalescing of a galaxy, we go through this infinite dance that looks so simple in an animation, but keep in mind what you're watching. Each point of light on that little graph is a star, just like our own. And each of those stars may have planets around them. And you'll see some during this gravitational dance get flung off into deep space. Others get pushed into the supermassive black hole, either the one of your own galaxy or another. And eventually that cloud coalesces into another fine shape. A lot of the hydrogen that's left over in gas form will actually start to move and shrink and form new stars. And it'll be an exciting period for new star formation. But what will happen to us? Kind of remains to be seen. We're in a relatively safe part of the Milky Way galaxy, being in the middle to outer edge of a spiral arm. And you may be asking yourself, why do spiral galaxies have spiral arms? Well, you might think that it's just like an octopus's arm, and that we are stuck in one of these arms and we go spinning around the center of the galaxy. But you'd be wrong. The funny thing is, the stars will always maintain their position around the galactic center. However, for reasons that are relatively unknown and haven't been studied well, as the galaxy turns, they actually just build up waves. So you can think of the galactic arms more as like a traffic jam than an octopus arm. At some point, our sun was at the leading edge of the galactic arm, to which we are now at the trailing edge. Just moving through, it got pushed as if it was almost a water wave, up over the top of the wave, and now we're falling down the backside of it. And if we were to allow 1 billion years of observation, we would rise up the next arm and down again. But this dance of going up and down the waves of arms as they pass by will not last forever, because as soon as we begin interacting with the Andromeda Galaxy, the life of spiral galaxies are over. There will be no more arms. For a while, the two supermassive black holes spinning around each other will form these tails, and those tails will then coalesce back into the center, forming the elliptical galaxy we spoke about earlier. But it will be a time of great upheaval. There is a chance that some solar system in the Andromeda Galaxy will pass very near our solar system. There's a chance that the gravitational forces will pull another star system from within our own galaxy closer to us and impact us. There is a chance that planets from either galaxy and any solar system will get flung out into deep space or be thrown our direction. And when our sun captures them, we could have a new 9th planet. Or they could impact us, and it could lead to the end of life on Earth. But lucky for all of us, again, that's a few billion years in the future. So I hope you've come out of this with a little better understanding of galaxies, what they look like, how they act, and what will happen when they collide. Next episode, we're going to talk about the Fujiwhara Effect, the thing that actually inspired this episode. I'm looking forward to it, and I hope you are too. Until next time, take care of yourselves and each other. Have a great day.